Well, greetings. I'm here to talk to you today about the geolocation of network devices. Maybe you've tried using programs like Google Maps. Maybe you've been to websites that ask to use your location. Or maybe you've just wondered how web traffic analytics can show where their traffic actually comes from. Well, it all comes from determining the location of network devices, whether it's a computer or a phone. And in this presentation, I'll answer these questions to help you learn about how it is possible to find out the location of your network devices. So there are four major techniques that are used by several vendors and individuals who provide services to offer the location of network devices. Normally, the vendors such as MaxMind or other location database services, they simply build associations with other geographic areas such as postal codes, cities, regions, or countries. Now, there's nothing inherently geospatial or related to a network device. It just does not have information about the physical location. However, there are still methods that we can use to identify the physical location of a network device, like a computer. I'll identify four different ways of finding a physical location of one of these devices today. We'll look at using the inference by named devices through the process of a network operation. We'll take a look at who is data mining, round-trip timing, and Wi-Fi location, which is located by GPS. Each one of these methods has its own strengths and weaknesses, but taken together, they can do a good job of making a judgment about how to find a location of a device that's on the internet. The first technique involves finding a location inference with a named device. Now, there are two primary ways that this can happen. The first one is very simple, and that uses the country codes of a domain name. Now, not all of the network devices that are on the internet actually use a domain name, but several do. Now, there are 247 different country codes that can be used to register a domain name through a registrar. Of those 247 different country codes that can be used as a top-level domain, 93 of them require a local presence. So in this case, uvic.ca, we can reasonably assume that this and any traffic that is coming to or from this any device on that network is coming from Canada, because the .ca top-level domain is a Canadian country code. So simply by looking at a domain name, we can figure out what country that network device is in. There's no guarantee of presence, however, even when there are local presence requirements for the registration of that domain, there still may be the physical location of the server or device that's on that domain may be in a remote location. However, when it's taken together with other information, it can be very useful. Another great technique to find the names of network devices in a network operation is using traceroute. Traceroute follows a packet of data from a source to a destination. And in this example here, I've performed a traceroute operation from my home to one of the root DNS servers. In this operation, you can see several names of physical locations identified here. We've got Fort Collins, Colorado, Denver, Aurora, we've got Illinois, New York listed here, Crosstown, Minnesota, Howard County, Maryland, and Hyattville, Maryland as well. So we can see a virtual line being traced from Fort Collins all the way to Maryland, where we can reasonably assume that this network device, this DNS server, exists. The second technique involves mining whois data. ICANN is a governing body of network addressing. And this organization requires public disclosure of a domain name registrant's physical address. And the registrars then are required by ICANN to host this information about these domain name registrants through Whois servers. And these Whois servers display the address of the registrant. Since this data is very publicly available, this is a technique that is very useful for finding information about just about any domain name and even IP address. Now, here's an example running a Whois operation for that same root domain server, DNS server, that I tested with the traceroute. During this operation, we can quickly see that we have some very valuable physical address information that is offered here. Not only can we see the country, the state, but we can also see the city, the postal code, and even the address of the building where this IP address is connected to. Now this matches very much the information that we had with our traceroute information. Both of them point to Maryland. And in fact, here we can even point much closer than just the state of Maryland. So as we combine techniques, our confidence increases and the quality of our assumption is increased as well. Another useful tool here is that with Whois operation for an IP address, we can see the subnet for this IP address. And that subnet can also offer us a way of extrapolating the location to other network devices that might be on that same subdomain. We might reasonably be able to assume that other devices that are on that same subnet might be in a similar location. The third technique that is used doesn't rely on naming so much and user-entered data so much as empirical testing to find the location. So hosts, this is based on some assumptions. Hosts that are in a similar network may be co-located if they exhibit similar network delays. And here we can also assume this only works when network traffic is routed as quickly as possible from the source to the destination. When both of those things are true, we can perform tests and compare the results of those tests to find matches based on the timings and see how the profile fits. Now there are three pieces involved here. There are probe machines, and these probe machines simply send out a signal or a ping request to the destination, and they keep track of the timings. Landmark machines are very important as well. These landmark machines are devices that are in a known location, and that known location is used by the probe machines to serve as a benchmark for timings to a device in that location. So there are several probe machines and several landmark machines. And the third part is the target machine. In order to find out the location of a target machine, ping requests are sent out to that device as well. Now, when these ping requests are sent out, the timing is captured by the probe machines and collected. For each one of the target machines, whether it's a landmark machine or the unknown location of another target, a vector of timings is collected for each one of those probes. And the basic idea is that vectors from landmark machines to the probes that match a vector from the target machine can be used to determine if that is in the same similar location. Let me show you an example. Here we have three different probe machines, A, B, and C. We have three different landmark machines, one in San Diego, one in Austin, Texas, and another in New York City. And the computer on the left side in California there, we don't know it's in California yet, but it's got a question mark there, and that's the one we're testing. Now in the little sidebar to the lower right, you can see that for the landmark 1, we have timings of 100, 200, and 300 milliseconds from ping requests from probes A, B, and C, respectively. And we perform similar profile tests for landmark 2 and 3. When we perform the tests to the target machine, we can find that vector, or that collection of ping times, to be very similar to the ping times that came from the landmark 1 machine. Since the target machine has a vector of timings that is most similar to the landmark 1, we can assume that the location of the target is near San Diego. Now this technique works very well when there are a large amount of landmark machines and a large amount of probe machines. The greater number, the better the tests can become. Now the results can be somewhat misleading if, in fact, the routing network traffic goes through poorly designed routes that aren't very efficient. It can also be held up or falsified if, in fact, some of the routers that manage the traffic from source to destination hold up the traffic and do not allow it to go through as quickly as possible. It can also be changed based on the bandwidth and the usage of that network location. A fourth method of determining the location of a network device involves locating Wi-Fi locations with mobile devices or GPS devices. This is an interesting technique that uses modern GPS technologies that are in cell phones primarily. And it works like this. A phone with a GPS finds its location from a GPS satellite. With those coordinates, that phone knows where it is. Then, when that phone connects to a Wi-Fi access point, a MAC address is associated or assigned to that phone so it can connect to the internet. At that point, the phone knows its location. It also has a MAC address of that specific physical device. And with that information, Google, in fact, with some of their Android devices, will post that information back to their servers. With that information in their servers, they can assume that other devices, such as laptops that connect to the same access point that the phone did, will be in the same location. This is a very interesting technique that they're using, and in fact, this is one of the ways that their location services are able to find the location of a laptop on a Wi-Fi network. By combining these four techniques using the inference of names of network devices, using whois information to determine the documented physical location of a network registrant, using a round-trip timing to empirically test the location of a network, and by using Wi-Fi location collected from GPS data, the combined collection is very useful for determining the location of a network device. This can be very useful for clients as well as servers and businesses who need this critical information about the location of their customers. Well, I hope you've learned a little bit more about how a networked device can be located on the face of the planet. Thank you.